So the way we have covered it was like the previous year, in which we covered solution, suspension, colloids and all. So a couple of things which are common with both we'll see. First of all, let us recall back what is known as solubility. What was solubility? The maximum amount of solute that you can dissolve in a given amount of solvent at a particular temperature is called solubility. Now that given amount of solvent we take as standard. So when somebody says that in a solvent, solubility means how much maximum solute can you dissolve. So that solvent we cannot keep in a variable mode, because if you keep in variable, tab to koi hisab nahi rahega na, you can go on filling as much as you want. So we freeze the solvent, and the standard way to freeze the solvent is 100 grams. How much of solvent? 100 grams of solvent. So let's take 100 grams of water. In that, we will see at a particular temperature, how much of say sugar can you dissolve. Now water is stagnant. How much? 100 grams. So our knowledge becomes easy to understand that what happens is, if you keep on adding sugar, after some time you won't be able to dissolve sugar, right? You can't add more water because water is 100 grams, but you can change temperature. So if we change temperature, again the molecules will gain kinetic energy and they will space up. More sugar will be able to go in. So this is a curve, and I'm dead sure such sort of questions will come, okay? Let's understand the curve first. Whatever is written is not that important for you. Try to understand the curve. On y-axis, we are trying to measure how much of solute can you dissolve, and how this curve is made. We have taken a beaker and we have taken 100 grams of water. So they have said solubility grams per 100 grams of water. So I have taken 100 grams of water in a beaker. Agreed? And then I made the room as 10 degrees centigrade. Look, this is the temperature in degrees centigrade. So I made the room what? 10 degrees centigrade or Celsius means the same. And then I started putting this compound A into that 100 grams water beaker. I found that I could dissolve how much? So this is 1, 2, 3, 4, 5 divisions make it 50. So I was able to, when the temperature was 0 degree, I could actually 1, 2, 3, 30 grams I could dissolve. Have you understood? And when I raise the temperature to 10 degree, obviously I expect more compound to be dissolved, soluble now. I was able to, how much could go in? From 30, it became something like say 33 grams. And slowly the temperature was increased up to 80. So when you go up to 80, then in that same 100 grams, you are able to dissolve how much? This is say 50, 60, 65 grams. If you look at this graph, this is a linear relationship. It's a linear. Now, since you study graphs, it's a linear. And it says at 0 degree temperature, aram se how much? 30 degrees of the compound A is going to dissolve. So in mathematics, if we go, this will show a linear relationship, some y equal to mx plus c. But this one is not linear. This is a curve, right? Curve means this is not linear. This will be something quadratic. It's a quadratic, it's a parabola, it's a quadratic. In x square terms it goes. Only for mathematics I'm saying, not required for chemistry. Okay, now let us see what happens here. While this compound dissolves only up to 30 grams, this compound dissolves 150, 160, 170, 180 grams at 0 degree. Right? And this one is very much more sensitive to temperature change. Look, when you increase the temperature by this much, you went up from how much? Only from 30 to something like 32. But here you went up from 180 to straight away 190. 10 extra grams with 10 degrees. Are you observing? The climb is much high. And let's say from 0 to 80. From 0 to 80, you started with 30 grams. You ended up how much? You ended up say 50, 60, 66 grams. 30 to 66 grams. You could only add additional how much? Say 36 grams. But if you look at this fellow, you started with 180 and you ended up at 360. Means double the amount of solute you could dissolve within this much of temperature change. Are you understanding? That means whose particle size should be small? This particle size should be small because the solvent is same water. 80 degrees when you heat water, water particles are going to go apart same for both of them. Water is not going to give you a preferential treatment. Must be that this particle size must be small. These are all things you have to read from the graph. Have you understood this? Okay. Now let us try and see some question. Now you know both the graphs, okay? let us try and see some questions. Okay, they say solubility of compound A. What is compound A? The red compound. Okay, A in water at 20 degrees. So what is solubility? How much does it dissolve in 100 grams? So 100 gram is standard. At 20 degrees, so let's look at 20 degree, and at 20 degree we find that it is 30 and 40 ke beech mein, it's around 38 grams. This one no one will give you wrong if you write 38 or 37. This is how you are interpreting the graph. So it is around, online children, you can open the book from your online what you call the online version also for more clarity. So we would write it is around 37, but the question is not that. They say the solubility of the compound is dash less than or more than similar to solubility at 60. So how much did we say? We said it is around 38. So let's look at 60. At 60 we are at 60 we are no, at 20 we are, this is 30, 38, and at 60 we are 50, 58. So 58 minus 38, 20. So we are dissolving 20 grams more when the temperature is at 60 degree. So now we have to, at 20, what is less? So at 20 it is 20 grams less than what is the solubility. Batao, samajh mein aaya ki nahi? Have you understood the question or not? Right? So reading graphs, you have to be very, very perfect. Okay, let's see the next question. Solubility of the compound B at 20 degree is dash. At 20 degree is always less. How much less as compared to at 60 degrees? So let's look at 20 degree. At 20 degree, I am 205. This is 210, so around 205 grams. And at 60 degree, how much I am? This is 300. At 60 degree, or they have already marked it. At 60 degree, it is 287. So 287 minus 205. Right? No issues. So it will be around 83. Nobody will give you a wrong if you write 83, 82, because these are approximates only. Let's see the next question out here. So the next question says, the solubility of dash increases more than solubility of dash with increase in temperature. Obviously compound B. Compound B shows a parabola graph. Here the slope is much more. Right? The rate of increase. See, if you see grams per degree centigrade. What is slope measuring here? Y data over X data. Grams per degree centigrade. So if you look at the slope here, tell me, look at the two graphs and you ask again that foolish question. If two childs sit on these ladders, which child will slide down faster? This child will slide down. Here the slope is much more. So the solubility per degree is much, much more here as compared to here. Okay. These were the three questions. What do you think will happen if you make a saturated solution at higher temperature and cool it slowly? That's our next topic, in which we need to understand the topic of crystallization. So let's first speak about crystallization. Okay. Crystallization is a method in which we prepare pure samples. Pure samples. Okay. So let's take one solution and let's make this solution very, very concentrated. One of the most common way of making crystallization, as I say, is making caramel. Okay. In caramel, what are you doing? You are making sugar solution of high concentration and then you start heating it. So more you are heating, first understand what's happening. The more you heat, water is going to separate out, more sugar is going to come up. After this heating, what you do, you immediately allow it to cool. As you allow it to cool, what will happen? The water molecules will shrink. So what happens to so much of sugar that went inside as a solution? They all separate out as a crystal. This is the idea of crystallization. And once the crystal is obtained, have you had this thing like in pujas and all, we give misri jo hota hai na? Misri is what? Sugar candy. Misri is a crystal. Similarly, you can have crystal of alum. You can have crystal of rock salt. Right? In lab, the most common crystal we make is copper sulfate. And we used to get marks based on how nice your crystal is. So how nice your crystal? Very easy. We will take concentrated copper sulfate solution and we will heat it. At that time when it is heated, note down, it is there in your NCERT also, you add slight bit of acid, sulfuric acid. Right? No, it's not speed up. It will not make the copper sulfate react with anything. Then you start heating it. And after you have heated, our teacher used to tell us that that process, heating happens in a small burner in lab, which is known as a Bunsen burner. And the process is time taking. There is where children lose marks. A child who is more eager to leave the lab quickly, he feels that it has become hot. It has not become hot. So every time it becomes hot, our teacher sir used to tell us, dip a glass rod and take it out. Leave it in air for sometimes, you will find granulations on the glass rod. So if you, how many of you, I don't think at your age you're making it. If you make burfis and laddus, burfi, or you make chikki, you have seen chikki? Burfi and laddu, like besan ki burfi if you're making, then we have this thing called chashni, right? And the word we say, ek tar chashni, do tar chashni. Tar means wire, means as the caramel is getting made, you just take out a sample on between two fingers and you stretch your two fingers and you see how many wires are getting, how many strands are developing. Just like you pull a chewing gum out, there's a one strand, two strand. So to get do tar ki chashni means it is much more thicker chashni, much more thicker syrup. And on that, the besan will be made to wrap up. And while being hot, you have to make the laddu or the barfi. That's the thing, okay? So in crystallization, what we do to understand that we are getting crystals or not, dip the glass stick into that crucible on which you're heating, take out the glass stick, glass rod, and hold it in the atmosphere sometime and see, you will find granulations. If you have made kheer anytime in house, or if you are making rabri, the spoon with which you do stirring, you again keep it outside, just go and touch that spoon, there will be granulations which you can see. That's actually the indicator that the crystallization, your heating is up to the mark. Then you separate out this hot solution and you pour it into a beaker. And after that, cover the beaker. Our lab used to happen in, say, forenoon period. Then come back again in the 7th period. Your crystals will come out almost like very beautiful crystals. And you get marks based on how nice and big. Then you can take them out on filter paper and actually wash those crystals in water. They are like glass pieces, hard enough. And you get the marks based on those crystals. So crystallization is a process of obtaining, and that copper sulfate which we'll obtain is called pure copper sulfate. Right. In the book, the language they will use is called blue vitriol. Copper sulfate is also known as blue vitriol. Copper sulfate, CuSO4. And in grade 10, you will study two things. In grade 10, we will study one more thing. So keep an eye on that word also. In grade 10, whenever you're studying crystallization, copper sulfate is also known as blue vitriol. Okay, TROL. Blue vitriol. What is the formula of copper sulfate? CuSO4. Now here there is a catch. If you write CuSO4, it is normal copper sulfate. This won't be blue in color. This is finer chemistry. CuSO4 won't be blue in color. CuSO4 is white in color. When CuSO4 takes moisture inside, and then we say dot 7H2O. This is known as hydrated copper sulfate. Hydrated copper sulfate. You will again read this in grade 10. This fellow is the one which is blue in color. And this water is known as water of crystallization. Hydrated salts are usually all colored except washing soda. Water of crystallization. It means that if you see CuSO4, it will be white in color. And if you see CuSO4.7H2O means one molecule of copper sulfate is surrounded by 7 molecules of water. This is called hydrated copper sulfate. Similarly, you can get hydrated washing soda also. That is Na2CO3. This is known as sodium carbonate. Also, many people will say this is washing soda. No, this is not washing soda. This is sodium carbonate. If you want to know its trivial name, then its trivial name is soda ash. Its trivial name is soda ash. If you want to know what is washing soda, that is Na2CO3.10H2O. This is washing soda. Both are sodium carbonate. This is called sodium carbonate hydrated. This is called sodium carbonate non-hydrated. If you take this salt, see, if you take this salt and you start heating it on a pan, all the water of crystallization will evaporate out, leaving you white color copper sulfate. Right? Similarly, you have alum, which we use for cleaning water, Al2SO4 whole 3. This is aluminum sulfate. But when you use it as alum, fitkari jisko bolte hain, then it has 24 molecules of water of crystallization. Al2SO4 whole 3 dot 24 H2O. This means crystal. Whenever dots, some H2O will be there. Like say for example, rust. Doesn't rust come out like flakes? This is also crystal. So rust is Fe3O4 dot XH2O. Depends on what type of atmosphere it is, so much of molecules it will take. This is rust. ठीक है, ये आगे जानेंगे 10th में. Not that much of an headache. All right. So we go back to our discussion. And so tell me, children, have you understood what is crystallization? So a crystallization is a process in which we can obtain pure sample of a compound by making crystal. How do you make a crystal? Take a saturated solution, heat it. After heating, pour out the solution, cool it atmospherically, and you get crystals. In your example, and a crystal is a solid that has a geometric pattern that you will study in grade 11s and all. Body-centered crystal, face-centered crystal. Crystals have got patterns, right? So let's see the crystal preparation that we have for us in our laboratory. So see how they are doing. So you use a glass rod, you have a beaker. This is a water bath. Water bath means, have you understood? You can't heat the beaker directly. So what they have done, they have taken a crucible. In that crucible, they have taken water. In that hot water, what I have done, the beaker has kept. Otherwise, you can straight away heat it in crucible also. We used to do in crucible directly. And then you'll have a tripod stand, Bunsen burner, and you have a wire gauge also. A wire gauge, typically the one on which you make kebabs and all at home. So this will be more like a mesh of a window. And then you are supposed to empty the content via the filter paper. The filter paper will take away any sort of dust. Why are you pouring it over the glass rod? This is the laboratory practice so that the thing does not. If you pour it directly over the filter paper, there is a chances that the pouring rate may be more. Acids and all are poured like this so that splashing does not happen. If you pour it over a glass rod, splashing will never happen. And then you get your beaker is there, and this lid is known as this is the dhakkan, which is known as the watch glass. And you keep it, come back after some time, you get crystals. You can take them out in filter paper and wash and clean them also. They won't break. Is this understood? Right? So you can get competency-based question from here. Okay. So take 1-2 ml of the saturated copper solution on a small glass plate or a lamination sheet. Let's try. Small, slides. Have you seen slides in biolab, the glass one? So you can just pour a little bit. Leave it for some time. What will you see? Some crystals, some small granules. This is the same question that I said. If you take out the spoon with which you are making kheer or rabri and you keep the spoon on one side, after sometimes you will find the spoon has got granules on it because there's a crystal formation. Crystallization is a common technique for separating pure substances crystal from homogeneous mixture. So what mixture did we have? We had a mixture of water, copper sulfate, and a little bit of acid was added so that the copper sulfate does not react. When new compounds are prepared, they're often accompanied by unwanted impurities. Crystallization helps to separate these impurities. That's why rock salt, all the salt that you eat are all in crystal form. Later they are powdered so that, but they are actually in crystal form. Okay? If you cool it in ice water, your crystal won't come out good. Immediately, in that case, they will the solute particles will just go up. It has to be gradually cooled. Because they will separate, plus they will take up some water molecules also. Very slow cooling. Okay. Now shows like these are crystals. Seawater to saturated solution to salt crystals. That's how you prepare. And then also you have quartz crystal. Quartz crystals are found in many caves. Okay, our next process that we need to understand here is known as distillation. So let's talk a little bit about distillation, and then we will understand what distillation is all about. While crystal was taking out a solid, in a solid form you took out, distillation is often used when you have two liquids, two or three more liquids. Imagine grade 8, fractional distillation, crude oil. So when you have 3-4 fragments which have varying boiling points, then distillation is a very nice feature. Let's put your common sense. I have a liquid A mixed with a liquid B. Both have mixed properly. Okay, you can't make out any difference in the layers. However, let's say two liquids. Let's take alcohol and water. Alcohol boils at 70 degree. Water boils at 100 degree. Right. So now what I do, I take a test tube and I seal it. I seal the mouth of the test tube with a cork, and I insert one tube, a blowpipe inside it, and I guide the blowpipe into another tube. Again, that also has a cork. Two things happen in this. No outside air can go inside here. No outside air can go inside here. The only possibility is something from here may go there. Now, this is a test tube which is having what? Which is having alcohol and water mixture. I start heating it. I know alcohol boils at 70. So I boiled it up to 80. At 80, what happens? No water will boil, but all alcohol has definitely boiled. After boil, what is their state? Vapor. Those vapors will do what? They will try to now escape through that pipe. And while they are escaping, the pipe is going from here to here. The pipe is going from this side to this side. What I do, I create a heat exchanger. Heat exchanger means I put that pipe in another tube in which I am running cold water, refrigerated water, and I'm taking the water out. Means a hot flue is coming to me. Flue gases, you know, the hot vapor is coming, and the vapor is also cooled as it is coming. So the vapor will now condense, and it will give tapak, 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 liquids will start dropping. So on the second test tube, you will have 100% pure alcohol, and on the white, what will you remain? 100% pure water. Have you understood? This is called distillation. The condenser technology is done. A condenser is like a heat exchanger. What is a heat exchanger? A heat exchanger is any sort of a mechanism in which we call counterflow heat exchanger. Air is coming from this side, hot gas is coming from this side. What will happen? The air will get heated and the hot gas will get cooled. It's like in cars. In cars, we have something called coolant. There's a fluid which is in car called coolant that cools the engine. But in bikes and scooters, we don't have coolant. In motorcycle, we don't have coolant. How is a motorcycle getting cooled? It's very hot. A motorcycle's engine block is right below between your two legs. Air. It's an air-cooled engine. So if you see the engine block of a motorcycle, it's a lot of fin structure. Aluminium, 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 like that. So when you ride the motorcycle, the incoming air is supposed to, it's called a counterflow heat exchanger. The air will go through it. Similarly, in factories where we are having hot gases which are coming out, why to lose their heat? Why to lose the heat? Those hot waters which are going out, hot gases, I don't want them. And suppose I'm also preparing steam in my particular industry. So what do? I will let those hot gases pass through the incoming water in a cross. So that we have got like tube, water will come in tube, gases will go from outside. So the water gets preheated. You're not losing the heat. Acha, common thing you must have also done. Let's say today I'm cooking only dal chawal in my house. How would you like to have it? Hot. Nobody likes cold dal chawal. So the dal is hot. I have poured it into a what do you call bowl, and I have closed it with a lid. It's hot. And I have also made my rice. But I would love to have a little bit of hot rice, you know. So what do? I place the rice bowl over the dal bowl. So as the dal loses its heat, the rice gets heated up and it stays warm. That's what we do in cold places. In cold places, generally we'll say khana garam kar lo. So you have some paneer. You heated the paneer on a kadhai. Now you have closed it. And on that heated paneer, the parathas that you made, just put the parathas on that. So in a sense, the parathas also get heated up. Nobody likes to have the cold paratha. And the paneer also will, you can't have very hot paneer also. So the paneer loses its heat, whereas the paratha picks up the heat. That's a heat exchanger. And we are going to do the same thing out here. So this is a homogeneous mixture. If it was heterogeneous, physically we could have separated. We'll see how we separate heterogeneous. So here what we are doing, a liquid, you heat it to vapor, you cool it, and you get the, what do you call, distillated. Distillation can also be done for what do you call, solid and liquid. Gandhiji, what he did, Dandi March, what he did, he took rice, he took salt water and he heated it. As a result, what got expelled? The water got expelled, and what was remaining was only salt. The other way, if Gandhiji would have needed water, then he would have had to do it in a closed environment with the vapor being collected in another test tube with a heat exchanger. So let's see this process. Okay, the process is something like this. This arrangement is called a Liebig's condenser. They have not named it. So see, you have a round bottom flask. What is this called? Round bottom flask. A round bottom flask has been corked out here, and we have put a thermometer to see what is the temperature, because I have taken, say for example, they have taken acetone and water, we have taken alcohol and water. What is acetone? It is the component present in your nail polish removers and all. Okay, so anyways, when you use nail polish remover, what do? You close the bottle and keep it. But the name, mama says what? Ud jayega, highly volatile. So who is going to get volatile first? Acetone will get volatile first. So the acetone vapors will now pick up, and you know the boiling point of acetone, so that you can control the heating, right? If you in higher end labs, you can also do this by electrical heating. You can find how much energy went in, and then you can actually find this process to do, is it economic or not. So okay, now the heat develops, the thermometer will give you your reading. At that time, acetone vapors enter this tube. This arrangement is called a condenser. What we are doing, we are putting in cold water from this side and taking out cold water. So this tube is continuously being flushed with cold water on outside, so that whatever acetone vapor goes in, the acetone vapor immediately cools, and I get liquid acetone on this side. So after some time, this will be 100% pure acetone, and this will be pure water. If it was alcohol and water, so the common sense you should use is, which fragment goes here? The one whose boiling point is low. You can't expect water to go here. It's like interrogation. Two of you have committed the crime and both of you are denying. So whoever's resistance is less to the stern action taken, he will break first. Batata hu, batata hu, batata hu. So acetone will say, batata hu, batata hu. So he will start breaking up. Same thing we use in crude oil conditioning plant, fractional distillation. So what is crude oil? Crude oil is a mixture of various components. So we have got petroleum gases, we have got petrol, we have got gasoline, we have got aviation fuel, you have got kerosene, you have got naphtha, you have got diesel, you have got asphalt, bitumen, fuel oil, so many things. All are in different temperature grade. The first to separate out are the petroleum gases. After that, naphtha will separate out, gasoline separates out, then kerosene, aviation turbine fuel, which is also kerosene, furnace oil, the same fundamental funda that we use. So if you remember the definition, what is fractional distillation? Fractional distillation is a process in which crude oil is separated into its components on the basis of the difference in boiling points. The crude oil is heated and is allowed to enter a fractionating column. And in that fractionating column, different temperature zones are maintained and different outlets are there. So the ones who are batata hu sir, they come out at the earliest. Who does not come out? The most stubborn one is the one which is known as bitumen, which you use for making roads. Tar, it will be left behind. So when tar is left behind, then you know. So that also they will show here. These are chalo matka techniques. This is crude oil. So petroleum gas comes out. After that, you have got petrol. Actually, petrol, before petrol, you get something called naphtha. Naphtha also, no, this is not naphthalene. Naphtha is a different component. Like my childhood was in oil, in townships of Indian Oil. So there, even with naphtha, many people run bikes and all. No, free. Naphtha, petrol, then you will get, petrol is not a word. The right word of petrol is a word we use. If you actually go to foreign countries, this will be known as gasoline. And in some countries, they will call this as motor spirit. Again, this is of two grade. Like you use Bharat Petroleum Speed and Bharat Petroleum Normal. They will call it as octane 91, octane 96. So then next thing we will get is diesel. You call it diesel, in some countries it will be known as benzene. Right? So diesel, then aviation fuel and kerosene. Aviation fuel grade is lower than kerosene. Kerosene is a better grade. Aviation fuel is the cheapest quality fuel that is used. In fact, I don't know whether you have faced when an aircraft is refueled, and if you are inside the aircraft, you cannot sit for some time. Smell is very bad. Okay. Then diesel, lubricating oil, the ones we use for engine oil, and at last bitumen is left, which you make for road. So these you should know how it goes. So you take a crude oil and you pass it through a furnace. It's called a crude oil conditioning plant, or it's called a COCP. Clear? Not needed. Nah. If this doesn't come out, this will not come out. Ultimately, gas comes out, but in the cylinder, there is no gas. Are you aware of that or not? A cylinder has only liquid inside it. Gas, you cannot get. The more liquid you put in, the more it is compressible. See, in the business of cylinders, now look like an economist. You have to ship it with truck. So what are you shipping? Iron. If you ship less gas, then you are an idiot. Because this is a product which cannot be carried like this. Nah? You have to carry it in these cylinders only. And if you are underfilling them, then we are doing idiotism. Therefore, if you see the tankers of LPG which goes, we call them bullets. They are all having liquid inside them. And it's very difficult to drive those tankers because the liquid continuously hits on both sides. It's liquid. But as soon as you open the cylinder, it comes in atmospheric pressure, it starts volatile. It's all liquid. Okay. Right. Next is paper chromatography, something which is very much used in forensic sciences, CID ko bulao. So chromatography. Let's understand what is chromatography. Very simple. In chromatography, it is a process in which you can separate the pigments present. Chromatography थोड़ा आपको यहाँ से बताते हैं. Wait, let me explain you from here. All of you have got these inkjet printers and all you have seen, right? So an inkjet printer prints so many colors. So the ink is basically combination of CMY or RGB, we say cyan, magenta, yellow, or red, green, RGB. Okay. Now, say suppose, what is chromatography as a procedure? Chromatography is stylish. What it does is, let's take a chromatography paper. A chromatography paper is something like a litmus paper strip. What is the beauty of this paper? The beauty of this paper is it can start absorbing fluid, right? In this fluid, what we do, how chromatography is done in labs. Initially, we will put one mark like this. Agreed? And in this mark, I'll tell you how they do chromatography. You will take your sample, whatever is your sample ink drop or whatever it is, and you will put 1 or 2 dots of ink drop out here. Got it? We know that this particular sample contains 2 or 3 more pigments in it. And we are supposed to separate those pigments. Now, how do you separate those pigments? After that, what we will do, we will put this particular, this particular strip in some mechanism will be there in which it will be introduced in a bath. And this bath is to be something which is actually volatile and can move. For ink, even water also does the magic. For ink, water will also do the magic. Okay. But for other things, what is that other thing? I'll tell you. So we will dip this. We will ensure we'll ensure that the strip is dipped in it. Right? Now slowly what will happen? The water will be absorbed by this strip, and this strip is held in it, and the water will climb up. Right? As it climbs up, it will pull this drop also with it. Now in this drop, imagine the drop to be 3 children, and these 3 children have different properties of laziness with them. Have you seen sometimes when you go to cousin's place and all, chalo, 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 ready ho jao, we are going to movie. 2 or 3 will be already ready. Some like Rishika is never ready. Okay. So you will find while 3, 4 have already gone out, the typical mama or the chachu who is taking you out, they have already gone out. 2 are the, oh, I'm coming, wait for me. They're laggers. Here also you will find something who are laggers. So we'd find typically like this, that let's say it has a yellow component, and the yellow component goes with water, and say the yellow component rises up till here. The whole thing has gotten wet, right? Then we have a pink component, and say the pink component has climbed only up till here. Say the pink component climbs up till here, and then we have a green component. The green component has gone up till here. So what we do, we actually create a reference charts for all. Okay, and say these are pure substances. These are some chemicals which are known to be very pure, and these chemicals you have actually found out, your book doesn't discuss all this, we call it RF, reference factors. So we know that some poisons, like say for example, if there is cyanide, potassium cyanide will go up till this much. This is used in forensic a lot. Okay, some other substance will go up till here, some other substance. This chart is made. Now you have victim's body and you have got a victim's blood. Then if you put victim's blood and you do the chromatogram rise up, then you can actually compare what all went up to their reference value. That means this substance must be present. Not there is a chemical test also. Both the tests actually confirm upon each other. Now I'll tell you what we used to do in grade 11. Okay, in grade 11 we used to use carrot juice. In fact, that experiment filter paper is right now here in this room, but it is of 1994, so marks have disappeared. So we take a circular filter paper. I'll tell you what we used to do in lab. We take a circular filter paper, and we will bring carrot from home, and mortar and pestle. So in that dik-chak, you will make some carrot juice, and everyone will be given carrot juice in small test tubes, right? Then you have to fold this filter paper and you have to find out the center. You know how to find the center, okay? And you will be given one Johnson's bud, sort of a cotton wick. Your job is to only dip it into what you call carrot juice, and put drops in it, drops in it. Keep on doing this for 30-35 drops till it becomes concentrated. By 30-35 drops, something will happen, which is that if I'm using carrot juice, this portion will now become very, very orangish, and it will become very, very soggy. It will almost tear out. When it tears out, take a cotton, and like you use in Diya, you make wicks, right? We make a cotton wick. Very interesting. See, chemistry should be always done in lab. So it will be, I'll show you this. My chromatogram is here. So it is now, the view is like this, and I have my carrot juice out here. Now I'm supposed to put a wick, white color. Okay, white, chalo white. So the wick will be made to pass through it. This is a wick which is made to pass through it. Correct? With the wick in it, you know what is a Petri dish? A Petri dish is a half circular type of a thing. So I will take a Petri dish, and I will just put the Petri dish in such a manner that the filter paper is over the Petri dish. Arrangement is like Lijjat Papar you have seen, a roasted papar on a katora. So Petri dish is very flat, small. Typically, like in hotels and all, you see glass ashtrays kept. It's like that. On that, this Petri dish, we use water here. We won't use water here. Water will not have the property to drag it up. So what we will use acetone. So here we will fill it up with acetone. Okay, na? And when we put acetone inside it, the wick will be allowed to dip in acetone. So the wick will suck out acetone, and the acetone will go into this concentrated solution. And what it will make, now you won't find something like this. It will spread up. So you will get radar charts like rings. So we will get rings like this. Different color rings will come out. They are the various pigments present in carrot juice. Carotene, xanthophyll, chlorophyll, all will come out. Your marks depends upon how many pigments you can separate out. How many pigments you can separate out. I don't know how much I can, it is still clear, but It should be there. Yes. Okay. How much it should be? Now when you hunt, you will never get it. One minute. 1 minute. Yes. This was our experiment. This is 1994. So this is the chromatogram filter paper. You can still see some layers. You see those radars? Chlorophyll, xanthophyll, carotene. So the experiment reads, to separate and examine the pigments present in green plants by paper chromatography, preparation of the extract and all. After doing those, we found circular bands of pigments are observed, chlorophyll A, chlorophyll B, xanthophyll and carotene. Carotene is responsible for giving you vitamin A, which is needed for your eyes. That's the quality of teaching we had in our very simple schools. No bakwas, सीधी बात, ठीक है? ऐसे करके you'll get different radar charts. You'll get another chart, say for chlorophyll, you'll get a chart like this, because this is spreading out in this manner. This is called chromatography. Now you understood. Let's see what NCERT talks anything extra from what we have spoken so far. Okay, let's see what NCERT speaks. So same thing, have you ever observed when a drop of water falls on something, on a sketch pen, on a paper, then whenever water falls on your painting or sketch pen written something, you'll see different colors separating out. That's basic chromatography. So let us investigate. So how they investigate? Too much of investigation. Right here, they put an ink spot, line, pencil drawn, chromatography paper, and then you put different lines that this fragment can go up till here only. This fragment goes up till here. Then only you get to know. Otherwise, you tell me, you found some metal or some mineral. How do you know it is manganese? No, but this should be a common question. How do you know this is copper? How will we know this is copper? Spectroscopy. How many of you have visited jewelry shops with your parents? Visit with your parents jewelry shop the day they are, sometimes we exchange jewelry. Have you seen? ये छोटे हो गए हैं, इनका देके कुछ और देके बड़ा कर दीजिए. Means basically they are selling jewelry. The day your parents are going to sell jewelry to buy new jewelry, please go with them. Wonderful experience. And if it is done in Reliance or any shop, so say suppose today Rishika wants to buy bigger earrings. She has got smaller earrings which are no more enters her ears or something, and they say that check how much there it is, we will add up some more and do. Now how does the shop believe that they have, what they have brought is pure gold? So the shop will first take the earring. See, these are very nice, and those earrings were given when she was very small, so a lot of kundan work is also there. So they will first ask, are you sure you want to exchange it, melt it? Yes. So first they will examine it and do some raw weight measurement, and they'll say this much is the weight, roughly around 80% of it will be gold, and today's gold rate is say 30,000, so this much is how much you can expect. Are you ready? So Rishika says, I am ready. The first thing they will do is they'll hammer out and break all the kundan and the stone. Now what are you left with? Gold. They'll take it in a crucible, and immediately in front of you they'll melt it, and melt it, it will become like a ball, and they will show it. You can see the whole process. No chori, nothing happens. The ball is made, and then they will take a big inkjet printer sort of thing, like a Xerox machine. So they will put that ball in that machine. That is a mass spectrometer, and you can at that time ask, where is the calibration certificate? The government of India should calibrate it. So the certificate they'll show. So the mass spectrometer, all jewelers will take 3 readings, and first reading it will come out, it will say, because now it depends upon how good quality of gold that original earring of Rishika which we had, it will depend how good the quality of gold was. So the first report will come out like this. AU gold, say it is coming something like 81%, right? Then with gold itself cannot work. In India, for ornament we use 22 karat gold. 24 karat gold will not work. 22 karat means there is still 2 parts, 24 is pure. So 2 parts something else. So then they will write silver. Silver will be some 7%. copper and other things, right? This is the first reading. And they'll say, we'll take the best of 3. So the first reading says 81%. Suppose her 2 earrings were 10 grams of gold. So they will multiply this with 0.81 because that's only gold. And they will multiply with the gold rate of that day, say 36,000. This is what they are ready to compensate you for the new gold item that you will take. Sir, there was some silver also. Now please give. No, nothing. Then they will again pass another reading. In the next reading, you will see it will come down to 79% also it may come. It all depends upon how the crystal is being read, right? Because the crystal will emit certain radiations. This is called atomic spectroscopy. That radiation will be compared with gold and they will find. Third reading, usually it doesn't. The third reading or the second reading comes more only. So it may come out. So that's why they say, why do our people so crazy to buy gold in Dubai and all? That gold is very pure. So if you have been blessed with some ornaments from Dubai in your childhood and those gold you want to melt in future, you will find the reading will come something like 96, 94, 98%. And sometimes poor people who have actually spent more but have brought from their villages, that gold will come out something like 81, 82. So in crude language, they say, Sone mein to khad milaya hua hai. The gold is not pure. So understood? That is how spectroscopy is done. So next time, if anytime you are exchanging gold, please go and exchanging gold not by gold coins, jewelry. Give old jewelry and buy new jewelry. But if you have some good stones on your earring, that is not valued. They'll just break it in front of you. Tack. Only the gold will be valued. That's why gold's value is so high. Understood? And jewelers nowadays give their own gold. Like if you go to Tanishq, you will get a Tanishq 10 gram gold. So when you go to any Tanishq in India, unquestioned, it will be bought from you at the same price on that day. Reliance has their own gold. Tribhuvam Bhimjilal Jhaveri, they will have their own one. Mangatram Jewelers, they will have their own. Malabar Gold will have their gold coins. Those are very pure. ICICI Bank also issues gold coins. So they are encashed at absolutely the same value. That is there on that day. Right? Understood? And India imports 74% of its gold. That's why the Prime Minister is saying, don't buy gold now. Because if you buy gold, the country has to import gold. The more gold you import, the more foreign exchange goes outside. Your foreign exchange becomes very, very less. How do you get foreign exchange? When tourists come to our country, there it is written, na? Rishika, Taj Mahal, 15 rupees, Americans, 500 rupees. That is where we get Forex. Or say your relatives are working abroad. They send money to you. That is how Forex comes. Or exports are made. That is when Forex comes. The more you buy, the more you import, the more you do foreign travel, you are pushing Forex out of the country. That is what the Prime Minister is asking you not to do now. The more fuel you burn, the more fuel you have to buy. And that time you have to trade in US dollars. So the dollars goes out. What happens is a Forex deficit. हम उतना Forex ला नहीं रहे हैं जितना Forex छोड़ रहे हैं. But at this scenario, one class of people are very happy. All IT professionals who actually work abroad. Why? Earlier they used to earn $1 and get 89 rupees. Now they are earning the same $1 in US. They are getting how much? 94 rupees, 95 rupees. Understood? Okay. So let's go back, and when we get into discussions, it just goes on. Okay, so this is all about chromatography, and the chromatography that you do is paper chromatography. I have said much more than what is written out here. Okay, next, how do you separate components of immiscible liquids? This is very easy. Immiscible means two liquids who do not mix with each other. Oil and water. Oil and water. Oil will be, say, we have taken a red oil and a neutral water. How will you do it? Take it in a, we call it separating funnel. A separating funnel will have a valve at the bottom. So fill it up. What should be at the top? Oil will be at the top because oil is lighter. So red on top, colorless. Start decanting, colorless, colorless, colorless. Means it is like India and Pakistan. There is a line of control. So go up till Punjab, Atari border, Wagha border, stop it. Because now there may be some oil also which may come. Separate the container. What did you separate? Water. Then you start running down from Wagah border to Atari border. You have entered Pakistan, right? That much you keep separate. That is oil water mixed. After that, from Wagah border, you start emptying it, and then you go to Lahore and Rawalpindi and all. Everything is Pakistan. Simple. Let's see that same thing out here. So they're going to separate oil and water. You will run it down. You will run it down till here. Then remove this. This is pure sample. Then again, take some bad container, run down little bit of this line of control, separate it, and then again take a good container and run out the list. This is called immiscible. Clear? Right. What is the next step we have? The next step is known as sublimation. What is sublimation? When a solid transforms directly into vapor and you bypass the step of liquid, it is known as sublimation. Camphor. Camphor, you know? पूजा की थाली में जो लगते हैं, कर्पूर जिसे बोलते हैं, camphor. Naphthalene balls. Odonil in your bathroom. Odonil gaya kahan? Sir, rodents eat it. No, odonil is sublimation. So in sublimation, solid to directly vapor. And from vapor, if you are coming to solid, it is known as deposition. It is known as deposition. Sublimates and sublime. Odonil sublimates to odonyl vapor. Odonyl vapor again sublimes to odonyl. Wish that was possible, but that's not. They're very clever. If that was possible, then we would not have purchased odonyl. We could have got the odonyl back. So how does this thing happen? They have taken camphor. You can take ammonium chloride also, right? See, fear is good for health. No homework tomorrow, no class entry. So they have taken camphor, finely powdered camphor, and you have put an inverted funnel into it, and you have closed it with cotton. So camphor is solid. The moment you heat camphor, camphor will vaporize, and by the time it goes up, it again cools down. Again, you will see camphor deposits on it. This is called sublimation. The best sublimatory example is dry ice. When you go to fish market and all, there are so much of ice cubes. If all the ice cubes were of water, then the whole fish market will become, fishermen will come in boat. So where is the ice going? The ice is all becoming vapor. The bad thing about it is dry ice is called dry ice. Dry ice is condensed CO2. Very cheap, very cheap. The problem is this is what people sometimes roadside lassi walas use for preparing your lassi. Never ever have that. It's not that it's bad. It will immediately cause throat infection. So you are supposed to have water ice only, not dry ice. So because the roadside lassi wala, if he takes 1 cube of water ice, then what will happen? It will melt down. Have you seen a ganda lassi wala on the road? Your experiences are very bad. You all don't know. So okay, you're eating something like say kala khatta gola. Have you seen in Mumbai that big gola? Katte rehte ho na dubki maar ke. So the way they make the gola, have you seen? That is all dry ice. Otherwise, the gola should have continuously dripped. Take some cube of ice at your home. You won't be able to hold it for some time. It will melt down. And you will see he will first take the cube of ice, and there is a, you know, usko randa bolte hain, iron jet plane jaisa, carpenter jisko marte hai na, there will be a blade. He will just make on juhu chopati, ghanch, and the whole ice will come out as crystal. Even my daughter and wife also, if they go to Delhi, Sarojini, gola khana hai, I straight away say, this is nonsense stuff you are eating. Then he'll take it and make a ball of it. And you happily, हाँ भैया कैसे दिए हो? अच्छा है. It doesn't melt. You're all eating dry ice. And that is because man can have 2 types of burns: hot burn, cold burn. My entire first job was on that. I used to work in cryogenics, liquid oxygen, -183. The bad thing is with if oil falls on your hand from samosa, you can put it into cold and get some relief. But if you get cold burn, what do you put? Oxygen runs through copper pipe, liquid oxygen. If you put your hand on that copper pipe and you take out your hand, your skin will be there on that hand. There are 2-3 marks on my legs also. Liquid oxygen has spilled. And if it spills, that mark will never fill up. Forever. You have to be very careful with cryogenics. Plant protective equipment is must. Otherwise, you'll be sacked from job, like goggles, everything, face shield, nitrogen, very dangerous. Have you seen the movie Terminator 2? The first one. Hey, you all don't see good movies. You should see Terminator 2, which is Arnold's movie, the movie from which he came up. You should see. That's such a nice movie. There will be a Chuta Boy and Arnold, that Harley Davidson motorcycle. The last fight scene is all with a liquid nitrogen tanker. And if you pour liquid nitrogen on tires of buses, the tire will just come out like breadcrumbs. Tapak, tapak. It will just come out like that. They show that scene. Chalo. So sublimation, and opposite is known as deposition. If the same vapors are allowed to cool, they will vapor. So sublimation is like this. The solid on heating becomes liquid, on heating becomes gas. Here the liquid phase is bypassed. So from solid you become what? Gas. And from gas you become solid. Yes. That beach ka, that bhoot face, from insan after death, bhoot to God. Here God to insan to God. Bhoot face is eliminated. Okay. Then they have talked about alloys, we have already spoken. Two solids do not mix properly at cold temperature. You can't expect copper and what you call brass, zinc to mix together. But if they are in molten state, they will mix thoroughly and they make solid homogeneous solution, which are called alloys, and that's called brass. So you should know what is brass. You should know what is bronze. Brass is copper and zinc. Bronze is copper and tin. And solder is tin and lead. Okay. Stainless steel is iron carbon. Suspensions we have spoken. How do you separate mud from water? Mud from water, centrifuging. That's another one. Centrifuging. So let me give you a gyan little bit on centrifuging is something like this. Blood sampling, लेकिन पहले समझो ना, समझो क्या चीज होता क्या है. Okay. When any object is made to have a circular motion, you have tied a stone and you are rotating it, the stone will always feel a force which will try to throw it outwards. That's why hotel gives you dal tarka in that bucket. You take the bucket and you rotate it, one drop of dal also will not fall. Because the dal is all continuously, it is in a circular motion, it will feel an outward force. Outward force is called a centrifugal force. Though not in your course, its value is equal to mv square by r, where r is the radius at which it is rotating, m is the mass, v is the velocity. More is the mass, more will be the centrifugal force. Just remember that. More is the mass, more is the centrifugal force. So what we did, we created a centrifuge like this, like an idli stand. Not idli stand. Inside pressure cooker, you get this separator stands now with holes inside it, like this. And here what we have put test tubes in these manners. Ana teras, okay? And this. And you put blood sample into it and you spin it at a fast speed. So blood has got plasma. You know, when dengue happens, then people don't donate blood. People donate the plasma. And for the donor, it's a big day. His blood will be first taken out. The entire plasma will be then taken out. And again, the repeat blood will be injected in. So you are also gone for one day when you donate the blood. So that blood will be, sample will be spun. So inside blood is a colloid. It has plasma particles, and plasma particles mass is more. If the mass is more, the centrifugal force that acts on it is more. So it will come out at the farthest point. So they are made like this tera. So at the bottom, it will separate out. Similarly, you can do for mud and water also. Mud and water, if you centrifuge, the mud will, see, now you might think, sir, then though you are trying to say that in what you call mixer grinder, everything. Mixer grinder has got a blade. Don't put that blade. Just centrifuge. Acha, have you seen food processor? In food processor, you are going to make ghee. To make ghee, first you have to make butter. So what do? You will first first we will take all the malais that we have stored for 1 month. We will put the malais, then refrigerated water, and you just run the spinner on. If you run the spinner on, the heavier mass things are the butter, they will all separate out and you can take out the butter like balls. And the water, do you throw it? If I am a cook, I will use that water to make my dough for the chapati or the paratha. It will be much more tasty. Like if you make rajma at home and the rajma is too much or dal makhni is too much, don't give it away to somebody. Blend it in a blender and use that to make your atta dough and make the paratha out of it. that is nothing but missi roti, which will be very, very tasty. Even when you make paneer, don't throw the water away. Use the water to make atta dough. The chapatis will be very much tasty. So that's centrifuging. This is also centrifuging. So you can say, no, sir, when we turn it, it mixes so well. That's a blender. You have got a blade inside. Blade is not allowed. You just घुमाओ उसको. मड वाटर को आप ऐसे घुमाओगे तो क्या हो जाएगा? मड एक जगह में चला जाएगा, वाटर अपने आप के ऊपर आ जाएगा. Understood? Very good. So centrifugation is also a process in which solid, immiscible solid in a liquid is taken out. Spinning game is like this. Okay. You should actually rotate like this and suddenly release the girl. Then what will happen? She will be in the impact of centrifugal force and she will fly away tangentially. So when you see Titanic as a movie, in that there is a the poor guy, Jack Dawson. He is one day invited to the first class because he saved the life of that girl, Rose Dawson. And there is a dance scene. So in that dance scene, they will show that Rose and Jack are dancing like that. The scene is not shot like that. The scene is actually the girl, Kate Winslet, who is playing Rose Dawson. She actually holds the hand of the director. The director is James Cameron. He takes the camera in this and they dance together. So when the shot comes up, it's the girl and the whole background is moving behind her. हर चीज को जानिए तभी ना खूबसूरती होता है उसकी. So this is centrifuging. That's all. We don't have anything. Powdered alum. This is called coagulation. Coagulation, you know, when you coagulant is something which can go inside and take everybody with him. Alum is a superb compound. Put some alum into your flush tank, water flush tank. If water is not good, just people write so many things on WhatsApp. Simple chemistry. Put some alum in your flush tank. It will bring all the impurities and keep it in one place. Put alum in water tank, swimming pool. It will take all the impurities, coagulate, and it will settle below. It's called a coagulant. Alum is a superb coagulant. ऐसे रख देगा नीचे. And now what to do? Just drink water from the top. Put some sand here. Yeah, that's how water filtration was done in our hostels also. We used to have large filters. Pebble will be here, stone will be here, sand will be here. Have you seen aquariums? So the aquarium is what? It's like a studio apartment for the fish. He sleeps there, he poops there, he eats there. Have you cleaned an aquarium? The day, where is all the fish poop going? They all get settled into that sand. The day you start cleaning it, the whole water will become hazy because you have just raked up the entire poop pond which is below. So how does it collect? It collects in that sand. That's why the aquarium will always appear very, very fresh and the filter is continuously running. So here also you put some pebble, stones, sand, filtrates and alum. The water that will be above will be crystal pure. People drink that. 4 years we have drank that water in government hostels. Sometimes water gets bad, so we'll see one person going in and again he's creating the bed. Then he'll pick out 1 or 2 lizards and he'll throw them away. They were also there. You think that every restaurant you go, there are no rodents in any restaurant. Oh, this place, our restaurant, there is no rodent. The entire Ratnadeep has no rodent. How is it possible? You pilfer so many things, 100%. Collage we have studied. So we have actually ended the chapter. Tyndall effect we have studied. Just because this book has been written in a separate format. Okay? Maths, try and procure that book, which I said, and we'll meet up in our next class. Until then,